All right, let's jump straight into this explainer. Today we're decoding the Cambridge Additional Mathematics syllabus, specifically subject code 0606, and we're going to do it by thinking exactly like a principal examiner. I want you to adopt a weightlifter mindset today, maximum effort in short bursts, because these high-mark questions require explosive analytical power. We're unpacking one of the most critical topics you'll face, solving cubic equations. We aren't just looking at this from a student's perspective. We're getting right inside the head of the person grading your paper. Because, when you actually understand what the examiner is searching for, the whole exam transforms from a stressful guessing game into a highly predictable, manageable process.
Now, you might be wondering, why are we focusing so heavily on solving cubic equations today? Well, look at this. It is an absolute guarantee it appears in every single examination series. No exceptions. This isn't one of those fringe topics that just kind of pops up once every 5 years. It is a certainty. And that makes mastering cubics a completely non-negotiable skill for your success. If you know a heavy lift is coming, you train for it until clearing it is just second nature.
Here is our game plan for today. 1. The cubic equation challenge. 2. Theoretical foundations. 3. The procedural framework. And 4. Examiner warnings and strategy. Let's dive in.
Section 1. The cubic equation challenge. So let's start with the root of the problem. Why do students consistently bomb at evaluating evidence and drawing correct mathematical conclusions with cubics? Mostly it's because they just see a chaotic mess of numbers instead of a structured logic puzzle. Enter the method mark strategy. This is literally your ultimate safety net during high-pressure exams. The principal examiner's reports bring this up constantly. Cambridge Additional Mathematics isn't just grading whether you got the final number right at the end. They are heavily grading your thought process. Think of it like showing your form in a heavy lift. If you can demonstrate the correct analytical process and show your exact working, you earn marks, even if you make a tiny, silly arithmetic error right at the buzzer. This specific strategy is how smart candidates ensure they never walk away empty-handed on a complex question.
Moving to Section 2, Theoretical and Conceptual Foundations. To actually secure those marks, we need to look at the underlying architecture. You can't just hack your way through the math. You need a rock-solid foundation. Top-performing students absolutely do not just memorize isolated formulas. They exhibit a deeply connected conceptual understanding. In fact, examiners explicitly state that candidates who reference cross-topic connections score significantly higher. But what does that actually mean for you? It means you have to understand how cubic equations relate to graphs, to functions, and to calculus. It's all connected. It's all about systematic analysis. When you tackle a cubic equation, you are essentially identifying the causal relationships between variables. That deep evidence-based reasoning is exactly what transfers seamlessly when the exam throws a totally unfamiliar context at you.
Section 3. The procedural framework. So how do we take that high-level theory and turn it into reliable points on paper?
It's one thing to understand the concepts, but quite another to execute them when the clock is ticking down. This right here is a brilliantly standardized 5-step sequence you must follow to leave absolutely 0 marks on the table. First, deconstruct exactly what the command words are asking. Second, extract the relevant data, your coefficients, constants, given roots. Third, select your analytical framework. Are you using the factor theorem, synthetic division, or comparing coefficients? Make a choice. Fourth, execute with crystal clear mathematical notation. And fifth, present your final answer using the correct terminology. Before we look at exactly how to interpret that data, let me remind you, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Hit that button and the bell icon right now so you don't miss out on these grade-saving strategies.
Okay, back to the framework. Within those 5 steps, your data interpretation is absolutely critical. Your ability to correctly extract info and evaluate it is what builds true professional exam skills. You have to pull the right mathematical relationships directly out of the text. For instance, if a problem casually states given that x minus 2 is a factor, you need to instantly, and I mean instantly, interpret that relationship and draw the evidence-based conclusion that f of 2 equals 0. Bam! That is the exact level of explosive precision the examiners are demanding from you. Section 4, Examiner Warnings and Strategy. All right, time for the most critical intelligence of this whole explainer. These are the exact traps principal examiners watch candidates fall into year after year, straight from the grading room. The classic trap? Using the completely wrong approach for the context provided. But the absolutely biggest examiner red flag? Failing to show your full working. Remember that method mark strategy we talked about a minute ago? If you just write down an answer and it's wrong, you get a hard 0, no safety net. But If you write down the wrong answer, yet clearly show the 5 steps of your working, you might easily walk away with 3 out of 4 marks. Never, ever fail to show your working. It instantly kills your chance at those life-saving method marks. Let's look at what separates the pack. This builds a crystal clear dividing line between your average, descriptive candidates and your top-scoring, evaluative thinkers. Standard answers just live in the basic analytical space, but the higher-order assessment objectives, they demand way more. Top-tier thinkers evaluate alternatives, they consider different mathematical approaches, and they justify their decisions with hard evidence right there on the page. They don't just solve the problem, they literally prove why their solution is the only logical outcome.
Okay, I want to give you a real game changer to help you remember all of this. Use a visual story method to encode these concepts. Research actually shows that creatively attaching complex math relationships to a visual narrative drastically improves your attention. For example, picture the factor theorem as a physical key unlocking a very specific door in a 3-story building, representing, the cubic power of 3. When you attach these abstract rules to concrete visual stories, they become virtually impossible to forget, even when you're stressed out during the exam.
As we wrap up this explainer, I want to leave you with a real challenge. Instead of just doing the math mechanically, how will you actively apply this procedural framework to think like an examiner? The next time you sit down with a past paper, stop and ask yourself, if I were grading this, where would I hide the trap? Keep applying that mindset and watch your grades skyrocket. And remember, students who implement these strategies see massive improvements, but only if they practice consistently. So, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.